Hey, welcome back everybody. Today our lesson is going to be on multiplying and dividing rational expressions. I don't have a ton of examples to do with you because I think we did a lot of the heavy lifting already in terms of the stuff that we did last week, which was simplifying expressions and kind of getting into that. So today is just going to involve an extra element, which is going to involve multiplying or dividing. And then, of course, at the very end, make sure everything is simplified as much as possible. All right, so let's go ahead and start into our notes here, which I've got some fill-in-the-blank stuff in here, which is, I think, good review as well. So I think a lot of the stuff that we've kind of covered before. So the first step is going to be factor. You want to factor all numerators and denominators. So you want to factor all numerators and denominators completely. So if there's anything that you can factor out of the top and the bottom, go ahead and do that. All right, the next step is going to be to divide. I guess I could also write factor, but divide out all common factors as much as possible. And the next step is going to be multiply from left to right. And one thing that's kind of important here, I want to make a little note here. Finding the LCD is not required or recommended, I would say, when you guys multiply or divide rational expressions. And we haven't even talked about how to find an LCD. That's going to be one of the last things we're going to talk about this school year. After I teach this, it always ends up being where someone is presented this problem after we've done LCD, and they're like, oh, I better find an LCD. But you don't have to find an LCD when you multiply and divide regular numbers. Like when you have to do 3/4 times 5/6, something like that. It's okay to just multiply left to right and just put 15 over 24. Of course, you have to reduce, right? You still have to reduce, but it is perfectly fine that you don't find an LCD of 12 and then do all that work. It's, the way we did it is fine. So if I just divide by 3, I'm going to get 5/8, which is our answer. Now, finding the LCD, actually, if I did that, it wouldn't actually make it wrong. It just makes it more difficult, I guess. It just adds another layer of work that you have to do, which I would avoid doing, of course, if I were you. But when you multiply and divide fractions, and rational numbers are just a fancy schmancy word for fractions, rational numbers, if we're going to multiply and divide them, don't find that LCD. Don't go through that step. That's just going to make things a lot more tedious for you. All right, and then there's a little bit of an asterisk here, which, when dividing, remember to flip, right? Flip the second expression. And I put AKA, that just means reciprocal. You want to find the reciprocal. Remember, I think I told you some students call it reflipical. That's kind of a good way to remember it. But reciprocal just means you're flipping that fraction. But this only applies to division, right? Only if you're dividing do you have to flip that second fraction, or in this case, it's called the second expression because they're rational expressions. All right, now the first one here, we're going to multiply. I don't have a ton of examples here because there's not a lot to this. You just have to practice this and make sure you know what's going on, but I'm not going to do a ton of examples. So for example 1 here, we've got 3x cubed over 2y multiplied by 6y cubed over 3x. And one thing that I would recommend doing, and I would try to get into the habit of doing, is cross-canceling. Cross-canceling is I know some people a little bit stubborn about it. They're like, I don't want to do cross-canceling. It's not really something I like to do, and it doesn't matter in the end anyway. It really doesn't. But cross-canceling is not, especially with the stuff that we're doing now. You definitely want to get in the habit of cross-canceling. For instance, like this 3 and this 3 right here, they can turn into 1. They cross-cancel each other out. They turn into 1s. And this 6 right here and this 2 right here, they could both be divided by 2. So 6 divided by 2 is 3, and 2 divided by itself is 1. Now cross-canceling, it definitely, makes things a little bit messier, but that's kind of the nature of it. And it does kind of, I think, at the end, make things a little bit easier. Right here you have 3 x's, and right here you have 1 x. So how do those cross-cancel? Well, you can just use quotient rule, which means that turns into a 2. So that turns into x squared, and that goes completely away. So I'm going to get rid of that. Same thing right here. Y cubed and y, we can use quotient rule. Again, that y can turn into 2. This goes away. So now look at all that's left there. What's left? Well, there's a 1, and that, sometimes that 1 matters, but it really doesn't do anything here. So we're going to do 1 times 3, which is just 3. And then we have x squared times y squared. And what is that? There's nothing complicated about that. That's just going to be x squared, y squared. Look at everything in the denominator. Everything canceled out. This 2 turned into 1. This variable canceled out completely. That canceled out. Everything's gone. So if you want to put it over 1, I guess you could. But that really is, I think I've used the word like superfluous. You don't really need to do that. It's unnecessary. Just write it as 3x squared y squared. And that's really all you have to do. Now for all the people too that when they're doing this problem, they're like, Mr. Oliver, I don't want to do that cross-canceling business. And I totally understand where you're coming from. So if you didn't want to do any cross-canceling, let's say we just multiplied everything. 3 times 6 is 18. And x cubed times y cubed is going to be x cubed y cubed. And then the denominator becomes, 2 times 3 is 6. Y times x cubed is going to, y times x to the first, I should say, is going to be yx. And then this all kind of comes out the same way, 18 divided by 6 is 3. 6 divided by 6 is 1. So there's your 3. And then you can kind of just deal with these x's. Like this x cubed will cancel out with that x. That goes away. That turns into a 2. This y cubed will cancel out with this y right here. So that will turn into a 2 right there. And look, we ended up with the same thing. We got 3 x squared y squared. And it's all the same. So like I said, if you don't want to cross cancel, it's kind of up to you, but I would highly recommend it because you're going to see the stuff that we're going to get into a little bit later this week, that it's going to be kind of a necessary thing. You definitely are going to have to be able to do it, but it just makes things a lot easier. For example, 2, the only thing that's a little bit special about this one is that we have to flip that second fraction. That's called reciprocal, and we have to change division into multiplication. So keep this first rational expression, first fraction, the way it is. Leave that. I'm going to change division to multiplication, and we're going to flip the second expression, and that's it. Now, one thing you're going to notice on this problem in particular is that, okay, we've got the 7 and the 5. Does anything cross-cancel with that? No, nothing goes into that. All right, we have a 3 and a 5 as well. We can also reduce fractions themselves, individually. But 3 and 5 does not reduce. All right, does this x cubed cancel off with anything? Well, I don't see any other x's. So no. Does this z cross-cancel with this z? Well, cross-canceling doesn't work that way. Cross-canceling only works diagonally, right? Like this, or up and down, vertically. But you can't go horizontally at all. So what's the moral of the story? Is that nothing cross-cancels. Therefore, when we multiply everything from left to right, that's going to be it. That's all. Our answer is going to be what it is. So 7 times 3 is 21. X cubed just kind of goes along for the ride there. 5 is going to remain in the denominator. And then you have 1z here and you have 3z there, which makes 4. And that is it. I would not change that into a mixed number. Do not change that into 4 and 1/5. Just leave it as is. Leave it improper, and that's going to be good. That's good enough. So, it would be very tempting, I think, when people do these problems initially, they look at these problems and they see right here, they see this, and they're like, oh, I can cross-cancel that. And you're very tempted to do that, but you cannot cross-cancel until you have an x there. I've had some students, I don't know how many years ago it was, but I had one student that told me, like, Mr. Albright, when I cross-cancel, I always think of it like this. I don't cross-cancel until I see the cross. The x is the cross, I guess. I know a cross looks like that, but an x is also a form of a cross, I guess, like a railroad crossing or something like that. But that's a good way to remember it. Like, don't cross-cancel until you see that literal cross, until you see that x there. And that's a good way to kind of think of it. On these right here, I'm not going to go ahead and talk through them, but I want you to perhaps pause the video and go through these on your own, see how you do. And I'm going to show all my work and see if everything measures up. So go ahead and pause the video, and when you're done, check them with mine and compare. See how everything matches up. Okay, that does it for the lesson here and for my examples there. Hopefully your examples matched up with mine. Let me know if you're confused on anything here. And that's it. Everyone have a great day. See you later.